How is everybody today?
Good.
Fabulous.
Wonderful.
Fabulous. All right, we're gonna continue on learning about circles.
Sick.
Thank you. All right. So we have three other sections to learn about circles. Today we're going to learn 2 of them, and we're going to apply some other angle relationships in circles. Okay. So the first one, I'd like you guys to just go ahead and write this down first, and then I want you to draw this diagram in the next flip chart with me. Okay. What this says is there's a relationship, okay, between the measure of an angle when you have a tangent line right next to a circle, okay, the measure of this angle and the measure of that arc, okay? Similarly, in a different color, there's a relationship between the measure of this angle and its intercepted arc. Okay, so draw this. I think this is the best way to remember it. Okay, so if you've got yourself a tangent line here, and you draw yourself a 90-degree angle and draw yourself a circle here, okay, the relationship between this angle is, this angle cuts right halfway through the circle, okay? So the relationship between this angle and the measure of the arc is of the circle is twice as big as the measure of the angle. This is the best way to remember it, because a lot of times people can't remember, do I multiply by 2, do I divide by 2? If you draw this, you can remember. Okay, so line N is tangent to the circle. Find the indicated measure of angle 1. So what's the relationship between the angle and its intercepted arc? We know the arc is 132. So what are we going to do with that 132 to find the measure of the angle? Okay, so I'm going to write, we're going to divide by 2, or we can cut in half. Either way, same thing. And what do you get? Okay? And then, now we're asked to find the measure of this arc, E, F, D. We're given the measure of this angle is 110 degrees. So now, exactly, by, and what do you get?
20.
Okay. Next one. We're going to do examples on all these after we learn the 3 theorems. Okay. Do you guys remember how to average? How do you? If I give you 2 numbers, how do you average? You add them up. You divide by 2. Okay. So you should have no problem with this. So go ahead and write this down. What this says is, if you're asked to find the measure of this angle 1, it's just the average of these 2 arcs. Okay? And angle 1 and this angle right here, what are those kind of angles called?
Vertical.
They're vertical angles. So those angles are going to be the same, but these 2 arcs are not necessarily going to be the same. Let me draw that for you. That's muy importante.
Perfect, sir.
Thank you. Thank you.
That is actually really good.
Okay, I'm going to try and really... There we go. So what I was trying to do when I was drawing that was I was trying to make sure that you can see that the intersection of those 2 chords is definitely not in the center of the circle, right? These are still vertical angles, so those angles are going to be vertical angles and therefore congruent, as well as those. Okay, those are also vertical angles. But these arcs here are different, okay? But you can find the measure of these angles here by averaging those 2 arcs. And these are vertical, so they'll be the same. Okay? So let's try it. So we're asked to find the measure of this angle here. So we are going to average the 112, and the 140. So you have to be careful how you do that on the calculator, and here is the explanation. It's on your notes. If you just type in the calculator 112 plus 140 divided by 2, the calculator knows order of operations, and it's going to divide the 140 by 2 first, and then add that to 112, and it's going to give you a different answer. Okay? So be careful. Make sure you put your parentheses, or if you don't want to deal with parentheses, you could do 112 plus 140, press enter, and then divide by 2, press enter. Did anyone do that?
I did.
Okay, so it's all good. So let me fill in these blanks here. Okay, so GH is, arc GH is 140, and arc FJ is 112. So when you average those, you should get, what do you get? So the measure of this angle here is 126 degrees, okay? Now, where they try to complicate things, and it's really no different, okay? Let's say they were not asking for the measure, whoa. Let's say they weren't asking for the measure of this x. Let's say they were asking for the measure of this angle here. How could you get that? Now that you know this is 126.
Multiply 126 by 2 and then subtract that.
You do 180 minus 126.
You could do that.
180
You're
minus
just making it
126.
more difficult. But you totally could do that. What?
180 minus 126.
Because this is a straight line. And together those two angles add up to 180. So you just do 180 minus 126 and you get to measure that angle. Okay, fabulous. You'll need that in a minute.
You're so smart, Daniel.
How are we doing? Okay, I'm going to really need your attention for this one. Okay, these three examples, they all look different, okay, but they are the same. So, if you have a tangent line, this is a tangent line, intersects a circle, 1 point, and a secant line, okay, 1, 2, or you've got two tangent lines, or you could have two secant lines. Okay, the relationships between the measures of their intercepted arcs, and I call this is the larger intercepted arc, this is the smaller one, okay? So the big intercepted arc, smaller intercepted arc. When you take those numbers, big minus little, and then divide by 2, you get the measure of this external angle. That's it. That's what this says right here. The measure of PQR minus the measure of arc PR, cut in half, gives you the measure of that angle. The measure of this arc XY minus the measure of this arc WZ, cut in half, gives you the measure of that angle. So it's the big intercepted arc minus the little intercepted arc divided by 2 for any of these problems. Sometimes your unknown is something different, which we're going to do in just a minute. Good times, right? Yes. Question?
How do you know how big the arc is?
There's no information on this one. In an example, they'll give you numbers, and they'll tell you what your unknown is. Sometimes your unknown will be the measure of the angle. Sometimes your unknown will be one of the arcs. But as long as you only have one unknown, then you can find it. Okay, big questions. All right, so let's try. Number 1, what's the measure of arc A, C, B? What's the relationship between, or given the measure of this angle, which I can't even name, A, B, something. Measure of this angle is 120 degrees. What's the measure of its intercepted arc?
240.
There you go. Any questions on that? Okay. Number 2. How do we do this? So those, we need to average those two, but when we average those two arcs, which we don't know one of them's x, we're gonna end up getting those angles right there, which is not what we're even given. What do we do?
One,
Yeah?
well, they're vertical angles, so 52 can go right over there. And then
Okay, all right, hold on. Let me use that 52.
no, 52 doesn't work because it's for the
Okay, but he's on the right track. What were you? We can use that 52. There is a little arrow. It's kind of hard to see, but it's right. This angle right here is 52 degrees. But can't we use that to get the angle that we need?
So it's
Daniel, you told us how to do that earlier.
180 minus 52.
Because this is a straight line. So the measure of, oh my gosh. This angle is 52. What does the measure of this angle have to be?
oh,
Okay, let me draw it out here. This angle is 52. What's the measure of this
128.
one? Okay, I'm just going to draw that right here. Okay. Are you guys okay with that? Okay, why do we need that?
Because it gives us the
It gives us the angle for the one above it, so then just multiply it by 2 and you get x. You have to multiply. You don't have to multiply by 2.
So we're going to have to average those two arcs, and it will give us 128. How do we write that in an equation?
144 plus x equals 128.
So
144 plus
hold on. Say what you said again.
144 plus x equals.
Okay, so when I add those two numbers
Then divide by 2. So
and then divide by 2, so when I average them, you still have an expression. We need an equation.
equals
Equals
128.
equals 128. When we average them, we should get 128. Perfect. Yes. Do you know how hard this was for you guys at the beginning of the year? You don't even remember. I remember. Okay, so solve this equation right now. Go. I'm telling you guys, beginning of the year, I'd say, this is equal to this. How do we write that in an equation? And everyone would be like, now you guys can do this. Good job. All right, what should we do first to solve this?
You multiply by 2.
For sure.
400.
Oh, shizzle. Okay. All right, so what am I getting here? Is that 40? Help me find this up.
X equals 1.
That's not right.
It's 256.
Thank you. Okay, so what am I getting for the value of x?
112.
And then, are we done?
No.
And
Yes.
Yes, we are. Okay. Any questions on that? Okay, we have problems like that in your homework, but I feel pretty confident you guys can do those now. All right, so Patrick, this is what you were asking about earlier. Now that we know the relationship between these intersected arcs, the large one and the small one, what do we do with those two values to find the measure of this angle, which, by the way, we already know? Well, we got to write an equation to represent that.
Wouldn't it just be 30 minus x over 2?
Hold on, there's no x here.
Or y?
This is that's the y. So the big intercepted arc is y degrees. The little intercepted arc is 30 degrees. And the measure of the angle is 26.
So y minus, what is it? Divided by 2 equals
Okay, hold on.
26.
Sorry. Go ahead.
Y minus 30 divided by 2 equals 26.
That's it. That's it. Everyone can do these problems, okay? The only thing, and I've told you guys this before, is that unfortunately these formulas are not on your formula sheet. You have to memorize them.
y equals 82.
So what do you get?
Y equals 82.
Y equals 82? 82? Okay, so y minus 30 equals, is that 52? And then add 30, yeah.
No, it's 82.
And we're asked to find the value of the variable, so we're done. All right, we're ready to move on. Okay. So we're just going to look at this vocabulary and then do an example, and then we'll look at that in just a minute. Okay. So segments of a chord. Okay, when two chords intersect in the interior of a circle. Okay. Okay, they're just any two chords, not necessarily diameters. Each chord is divided into two segments called segments of a chord. So this chord is divided into that segment and that segment. And then this chord is divided into this segment and that segment. That's all that's saying. So here we've got two chords. Notice this is not the center of the circle, it's just two random chords. Okay? So this is just something else we have to memorize. Okay? When you multiply the lengths of segments, they equal each other. So A times B equals C times D. That's it. Fortunately, you have to memorize it though. So I'm just going to write an X here because we don't know the value, which we're trying to find. So 16 times X equals 8 times 4. How are we doing?
Good.
Okay, solve for X. I got 2. Pretty basic, right? Everyone can do this until you have 27 formulas in your head and then you're like, what do I do again? Okay, but you guys can all do this. All right. Back to the vocab. Two things, secant segment and an external segment. Okay? A secant segment is a segment that contains a chord of a circle that has exactly one endpoint outside the circle. So, here's a secant segment. It hits the circle twice, 1, 2. So there you go, there's your secant segment. Okay? The external segment is the part of the secant segment that's outside the circle. So, that's just this external segment. We call that external, outside. It's on the outside of the circle. All right, so let me erase these. Okay, these are different theorems, okay, but I want you to look at them the same way. All right, so in this theorem 10.15, you've got two secants, okay, and here you've got one secant and one tangent, okay, but the relationship is the external part, the external segment, times the length of the entire segment equals the external part of the segment times the length of the entire thing. So the external part is A times the length of the entire segment is A plus B. That's where the A plus B comes from. Equals external part of the segment is C times the length of the entire segment is C plus D. Okay? So if you look at this the same way, external part of the segment, the external segment is B times the length of the entire segment is B plus C. Okay? Now we get to the tangent line. The external segment is, the length is A. And what's the length of the entire segment? It's the same as the length of the external. So we're just going to write A times A. So the external part times the entire thing ends up being A times A. because the external part is the same length as the entire segment. So that's where the a squared comes from. Okay, so let's try it. Find the value of x. All right, so external times the length of the entire segment. What's the length of the entire segment? I'm going to write 6 plus 4. If you want to write 10, that's okay, but I want everyone to see where that's coming from. Equals 5 times, what's the length of this entire segment here?
5 plus 5 plus
Right here. So, I'll give you a minute. This you don't have to distribute, because this is a 10 times 6, so that's just 60.
Seven.
7. Oh, it's 35.
It's 7. It's 7 because it's 6.
25, and then don't forget the 5 in front of the x. You have to distribute the 5 and the x as well. Okay. I like distributing. I was trying to explain that to my son the other day.
My teacher always explains that.
Colin wants to say a secret phrase.
Secret phrase! We need a secret phrase. You guys, we forgot them in the last video. Alright, let's put one in now. Colin, what's secret phrase? An appropriate
Oh,
school.
you just said.
School
You just
appropriate.
told me you wanted
No,
a
I
secret
didn't. I don't have
phrase.
Anybody?
I have a secret phrase.
Otherwise, I'm gonna make it up.
Oh, you better hurry.
I don't have one.
Okay. This video is already super long. I'm so sorry. The first secret phrase is happy birthday, Justin Bieber. Yes. Okay. All right. So
X equals 7.
find the value of x. You found the value of x. Okay. How do we set this one up?
You do
External times entire length equals external times entire length. External times entire length equals external times what's the entire length of
9%.
Okay, go.
Seven. Yeah.
X equals 7.
Colin, I already said it. You said yes.
I said it first. Hey, Colin. How many
Okay.
applications did he give you?
This one's not asking for x.
What does it say?
Oh, it's not? Oh, yeah.
This one's asking us to find the length of ST.
Yeah.
Oh,
So,
so
wait.
it's 9 plus 7. It's 16.
X would be 7. Yeah,
16.
16.
16.
Wait,
No.
isn't ST just this length here?
Yeah.
So it's just
So it's just 7.
7. Yeah, I was right. Fun, Dave. I was right.
No, you weren't.
Done.
I said 7 like 4 times.
That's not the answer. It's S.
Oh my gosh, you guys are all right.
Another
This bump. 7. This bump. 7. This bump. I heard you first.
Yeah.
Okay.
Yeah.
Yeah.
Hold on, hold on. Thanks for coming out. Peace out.
High five.